Types of searches, linear and binary. So searches are used in finding specific data based on a search criteria. Searches aid users as programs can potentially hold large amounts of data that is accumulated over time. In order for users to find data in a timely manner, users will need to have access to search tools that allow them to enter their search criteria. Two types of searches that may be incorporated into programs include linear and binary searches. So the first one is that of a linear search, which makes use of an algorithm which will sequentially analyze a list of data in order to find a result that meets the search criteria. So what we're saying here is it is basically going through an array in its existing order. So whatever order the data has been entered into the array previously prior to the search, that is the same order the search will go through the array. Okay, so for that reason, it's a very simple search. It's just going through an array in order, and it doesn't need that array's data to be sorted in any way prior, because it's just going to look at it in the order that it's in there. Okay, so let's look at an example here. So here is my array of data. It's just the numbers 1 to 9. And I'm going to search for the number 7, and I'm going to track how long it takes me to get to the number 7 when I do this search. So what will happen here, it's going to go through it sequentially. So it's going to start at the number 1, where check 1 takes place, and then go through 2, 3, 4, 5, 6, and then bang, there's 7. I found the number 7. The search is now complete. It took 7 checks to find it there. So it was good because I didn't have to sort the data prior in any way, and obviously it found my number. But it took a while to get there, and like this is obviously a simple example, but imagine that number was 700 or 7077. It would take much longer to get there and actually find my actual searched item, okay, if it has to go through all the data sequentially. Okay, but if the data was unorganized, okay, well then that's fine because it would eventually get there and I didn't have to do anything prior for it to get there. So essentially, this is the actual things about the actual linear search. Okay, in that it does not have to have data existed in a sorted form, which is the good side of it. But the downside is, as you saw, that it takes a lot longer to get there. It took a while to find my number, okay? And that's obviously in comparison to a binary search, which we're going to take a look at now. So in a binary search, it involves the analyzing data by starting at the center of a sorted array. So data must be sorted in this case because we're going to be comparing values, and based on our comparisons, eliminating areas where the data couldn't possibly exist. So what happens is it gets to that central number and then it analyzes the central element in relation to the search criteria. It will then eliminate half the actual array's data because it does not fall into the area where the search criteria could be based on where the search currently is. Okay, so items that do not relate to the current search criteria will be eliminated from the search. And then the remaining of the array that was not in that eliminated area, it will then find the central point in that area and then do the same thing. It will find the central point, it will compare data to the search criteria once again, and then eliminate values that couldn't possibly exist in once again. Then find the central point in the remaining values, and so on. That process goes over and over until eventually it will find the actual value we are looking for. So let's use my same array once again. And obviously it is sorted and it has to be sorted for this to work. Okay, once again, we're looking for the number 7 and we're going to tally our checks. So the central point here is the number 5. So check 1 will take place there. And then what happens is it compares 5 to our search criteria. Well, 7 is greater than 5. So it's going to eliminate the numbers 1 through 4. 7 does not fall in that area, and that's why the data must be sorted. It will then go to the next actual central point of my remaining items, which we've got an even amount of numbers here, but that'll be 7.5. So it'll look at 7 next, which is the answer. So bang, that's it. It found my number after 2 checks. Okay, 2 checks to find. The search is now complete. So it was much faster than the actual linear search. So in the comparison, binary searches are much faster than linear searches, though the data must be sorted for the algorithm's logic to work correctly. Okay, so I hope this has given you an understanding of different types of searches. Essentially, that linear searches involve going one by one through every piece of data within an array until we find our search, whereas a binary search obviously finds a central point and pretty much splits the actual array up based on the search criteria, and then with its remainder, okay, then finds a central point and does that process so on until it actually finds the process. So through its algorithm within the array, its search, okay, it is much more efficient, though the data must be sorted.